question number 3. The question is the wave equation of a sinusoidal wave traveling is given by. So we have a equation for sinusoidal wave, okay, where y and s are in meters and t is in second. Sketch the graph at t is equal to 0, which means that we want to plot, or we want to sketch the graph of y against s, because t is equal to 0. So for this question, the sketching must be from 0 to 2 lambda, meaning that we need to know the value of lambda of this wave. So how do we get the value of lambda? Is from the equation. So from the equation, we have y is equal to 0.15 sine pi t plus 2 pi s. So we compare with the general equation, a sine omega t plus ks. So from the value of k here, that is equal to 2 pi, we can have the value of lambda, that is equal to, lambda is equal to 2 pi over k. So 2 pi over 2 pi, and then we can have lambda is equal to 1 meter. To do the sketching, so we normally have a table. So in that table, we fill in the x and y value for at least one wavelength. Okay, so our wavelength is equal to 1. So we start with 0. Half of the wavelength is equal to 0.5. Here is 0.25. Here is 0.75. Okay, so what we do here is we substitute the value of x here with 0, and then we get the value of y. So what is the value of y? Then we repeat the same thing. We substitute the value of x, and what happens to y? And we do the same until the value of one wavelength. Okay, so when we do the substitution, okay, when x is equal to 0, you have y is equal to 0. So I have calculated for you. So when s is equal to 0, y is equal to 0. S is 0.25, we have 0.15, 0. So we want to plot the graph of y against x for at least 2 lambda. 2 lambda. So label your axis. This is meter. X also is in meter. Okay, so we start with 0. So when x is equal to 0, y is equal to 0. When x is equal to half of the 1/4 of the wavelength, so lambda is equal to y is equal to positive. When x is equal to 0.5, half of the wavelength, we get 0. And when x is equal to 3/4 lambda is negative, then we plot the graph, which also prove our equation. Okay, we are proving the equation because our equation is in the function of positive sign, so the graph form must be in positive sign form. Okay, so what we draw here is only for 1 lambda, meaning that we need to have one more wave. So this is our answer. So we need to obey what the question asks us. So if the question doesn't give us any limit, so minimum you need to have at least 1 lambda.